Hello class, these are our notes for Algebra 1. We're in section 5.5 today, representing exponential decay. So we have been working in the beginning of the chapter on what exponential growth looks like, and then we learned how to write those equations. In the last section, we learned about exponential decay, and now we're going to start looking at how to write those equations. And we're looking at a graph today. So I don't think that we have written an equation that's quite this difficult before. So step A, they're really carefully stepping us through this problem, is to create a table of values that represents the graph. So I'm just going to go ahead and I can see my first point here is really 0, 200. And then I have 180 to 162. So remember, ordered pairs are always x and y. So it doesn't tell me what letters to use here. So I'm just going to go ahead and use x and y. So let's go ahead and make our xy table. And my x values are 0, 1, 2, 3. And when my x is 0, my y is 200. When my x is 1, my y is 180. When my x is 2, my y is 162. And then my last y value is 145 and 8 tenths, 145.8. So next they want us to explain what the point 0, 200 represents. So I guess we really better go back and read the word problem. It says the amount of caffeine in a person's body changes exponentially. Below is a graph showing the amount of caffeine in a person's body measured in milligrams over a period of time measured in hours. So our x is our hours, and our y is milligrams of caffeine left in a body, or in a person's body. So it must be that you drink the coffee, and then you have this exponential decay happening where you're left with a certain percent of caffeine every single hour when they measure it. So that's kind of what's going on here. All right, so 0 to 100 then, that means we're going to be looking at a time of 0 hours and 200 milligrams of caffeine. So remember that 0, 1 is always like where we start at. So I'm going to say there are 200 milligrams of caffeine in a person's body at the beginning, or at the start, or when we start measuring. So many different ways you could word this. Using the given information, find the fraction of caffeine in the body after each hour. So I feel like there's different things here. They're looking for the fraction of caffeine that's left in the body after each hour. So when I look at what's going on between those first 2 points, right, I'm looking at what percentage of caffeine is left. So I have, after 1 hour, I have 180 milligrams, but I had 200 at the start. So we're going to make a fraction out of those two. So I'm going to write 180 over 200. And if I reduce that down, I could reduce it down and say, we'll divide them both by 10, and that happens. And then divide both by 2. 18 divided by 2 is 9. 20 divided by 2 is 10. The other route I could take is if I directly take 180 and divide by 200 on the calculator, I get 0.9. And then remember, when I read this, this 9 is in the tenths place. And so it's possible for me to convert that decimal to a fraction as 9 tenths just by reading it. So 9 tenths the fraction, or 0.9 like that, which is really read as 9 tenths, those are both equivalent. So they say fraction. I'm thinking that this version is probably easier to look at. So, because I am a curious person by nature, I don't want to just stop after I've looked at the first two numbers. I want to check a couple more and make sure that this is really 9/10 all the way through and I haven't screwed something up. So, like, I want to see what's happening from 162 to 180. So, let's go ahead and divide those out as well. And because I know what the decimal should be equal to, I know it should be equal to 0.9. I'm just going to directly divide this out by a calculator. I'm not going to try to reduce that fraction. So when I take the top number, 162, I put that into my calculator first. I divide by the bottom number, 180. I get 0.9. So still looks like 90% left after that second hour. Let's go back and do one more because they do give us one more set of ordered pairs. And so in the next hour, from 2 hours to 3 hours, so at the end of the third hour, I've gone from the 162 to the 145.8. So I'm going to take my last number, my 145.8, what happened at the end, and I want to divide at the beginning of that interval, 162. So 145.8 divided by 162. The tricky part for me is remembering when I scroll. 145.8 divided by 162. And again, I'm just going to divide this one on a calculator, which means I'm doing top divided by bottom. So you put your top number in first. That's been a really common mistake this year. And this one equals 0.9 again. So what this tells me is I am keeping 9/10, right? I'm keeping that much in my body. So that means my growth rate or decay rate is 9/10. So let's write growth, decay. I mean, it's kind of, I don't know. I'm spelling decay wrong, so I'm going to stop here. Is 9/10 or 0.9% or 0.9, or let's even say 90%. And the amount that I'm losing, not my growth, I guess this isn't your growth rate. This is your growth factor. That's a really kind of tricky distinction. So the one that's in your formula is going to be the factor. So let's fix that. So this is our growth factor. But I am really decaying by 10% each hour. Right? So my growth or decay rate is like a negative 10%. So this is one of those things we're going to make a big deal of as the chapter goes on. I feel like factor versus rate is going to be kind of tricky, so we're really going to have to work on that a lot because you can see that even I'm kind of screwing it up. So when I write my equations, it's always y equals the start times that growth factor, the amount that we're multiplying by each time, and then raised to the x power. So, oh, and they don't want me to use x, they want me to use t. Oh, and I'm in the last step already. Okay, so I'm kind of getting ahead of myself. So this part right here and part C, we were just supposed to find the percent, right? And we found the percent, it's 9/10. That's our growth rate. So we were done on this one. The next step, though, of course, is to write that equation. So we want our caffeine to be in Y, our time to be T in hours. And so we're going to have Y equals our start times our growth factor. So whatever we're multiplying by each time. And then raised to the x power, but in this case, we're not using x, we're using t power. So that means I'm going to write y equals, at the start at time 0, I had 200, or the person had 200 milligrams of caffeine in their system. The amount that we have the growth factor, what we're multiplying by each time, is 9/10, and it's going to be raised to the t power. So I feel like coming up with that 9/10 part thing is kind of new. So if you need to, you could go back to your table and you could say like, hey, does that 9/10 really work? Let's take 200 and let's multiply by 9/10 and make sure we get 180. Let's take 180, multiply by 9/10, make sure we get 162. Let's take 162, multiply by 9/10, and make sure we really get 145.8. So that might be a good exercise for you. So our goal today is kind of a couple different things, that we start to get some practice with writing these kinds of equations, right? We wrote an exponential decay equation, but I know we did those yesterday as well. But I think the bigger part is really working on this fraction, right? And being able to get that data, figure out that fraction based on the graph. So we're definitely going to be practicing that some more. As always, class, if you have questions, please make sure you ask.